to this webinar. Before we begin the presentation, I want to provide you with a few housekeeping items. On your screen, you will see a taskbar with icons. Each icon is assigned to a particular element of today's webinar. Click on the person icon to learn more about today's speakers. Throughout the presentation, you can network with others or submit questions to the speakers in the Q&A and chat box next to the slides. Download resources from the cloud icon. After the webinar is over, please take our survey to tell us how we did. Today's event is being recorded and archived and will be available within 24 hours. For on-demand questions or comments, send us an email by clicking Need Help? Email us. If you experience any technical issues today, please refresh your browser by hitting F5 for PC or Command R for Mac. And now I'm excited to turn it over to today's moderator.
Good afternoon and welcome to this webinar, Applying VRF in Third-Party HVAC Systems. I'm your moderator, Herb Warple, Editor-in-Chief of Engineered Systems. This event, brought to you by Engineered Systems, is sponsored by Mitsubishi Electric Trane HVAC US. Thank you for joining us. Today's presenters are James DeBerry and Tom Greco. James DeBerry develops and executes marketing plans for Mitsubishi Electric's commercial new product launches and existing product maintenance. With extensive corporate marketing experience, he most recently served as Senior Marketing Manager at AT&T Atlanta. He is a graduate of the University of Georgia with a degree in journalism. Tom Greco is the Director of Controls Applications at Mitsubishi Electric Trane HVAC US. Through his engineering background, sales experience, and 10+ years in the commercial HVAC field, he has accumulated a broad understanding of the industry. Tom began his career as an automation engineer before transitioning to commercial HVAC applications and sales roles. He earned a bachelor's degree in mechanical engineering from the Wentworth Institute of Technology in Boston. With both technical and customer-facing experience, he is able to effectively manage teams and help implement new technologies. Don't forget to submit your questions, and later in the program, our presenters will address as many as possible. Today's event is being recorded and archived on www.esmagazine.com/webinars. And now, I'm excited to turn it over to today's first presenter, Mr. James DeBerry. James?
Thank you very much, Herb, for that introduction. Hello, everyone, and welcome to today's webinar. Today, we'll be discussing VRF technology and applying VRF technology with third-party HVAC systems. On behalf of Tom Greco, I'd like to thank you for the time you've chosen to invest in today's session. Tom and I both believe you'll find the content presented to be quite valuable. We're planning to spend the next hour discussing variable refrigerant flow, or VRF technology, along with a section on VRF manufacturer controls and third-party integration, and will gain a better understanding of how VRF integrates with existing HVAC equipment, whether it's ventilation equipment, auxiliary heating systems, or other types of equipment. Specifically, here are some of the topics we'll talk about and the learning objectives for today's webinar. Understand why VRF systems are positioned to be the primary heating and cooling technology. Discuss why VRF systems are applied with existing and complementary HVAC equipment, including sharing application examples. And lastly, understand how VRF manufacturer controls and services facilitate integration and solve building challenges. Modern construction requirements, sustainability, and the rising cost of energy are driving the adoption of variable refrigerant flow, or as I mentioned, VRF technology for short, not just in the United States, but worldwide. Sustainability-driven legislation, utility incentives, and concepts such as strategic electrification that seek to significantly reduce our dependence on fossil fuels are upping the demand for an electrified built environment. VRF systems, as an electric-powered, energy-efficient technology, are positioned to become the primary commercial heating and cooling technology of the future. However, VRF manufacturers recognize their systems will not be the only HVAC equipment in a building. Building owners, facility managers, and project teams will be responsible for buildings where VRF systems are applied with existing and complementary third-party HVAC equipment. As an example, in new construction, third-party HVAC equipment may complement the primary VRF system by providing mechanical ventilation or conditioning zones with unique needs. Another example, in retrofits, existing third-party HVAC equipment may remain to service select areas or complement VRF equipment, perhaps as an auxiliary backup system. In this presentation, we want to demonstrate that this integration of varying equipment can be seamless by partnering with VRF manufacturer controls and services. Now let's spend a little bit of time talking more about variable refrigerant flow technology and how it can help solve some of the challenges in today's marketplace. Variable refrigerant flow technology was introduced in the United States over 15 years ago after many decades of prominence throughout the rest of the world. In fact, in some parts of the world, VRF accounts for over 70% of the HVAC market. Instead of moving conditioned air through ductwork to the space requiring conditioning, VRF delivers conditioned refrigerant directly to that space, eliminating the requirement for long runs of ductwork, instead by using small diameter piping. VRF systems save money by modulating refrigerant flow and using only the precise amount of electricity required to maintain the set point. This is done through inverter-driven compressors. Inverter compressors are always running in the background, adjusting the compressor and modulating the speed in real time. By ramping up power to the compressor when needed, an inverter provides a more accurate, on-demand approach to temperature control. If your room's temperature is already a comfortable 72 degrees, for example, an inverter may slow the compressor's engine to a crawl. If your room is really warm, say 85 degrees, the inverter will push the compressor into high gear, reducing that temperature more quickly. This allows the system to more efficiently maintain the set point temperature without drift and energy consumption spikes. This is another source of energy savings, as this eliminates the energy-intensive start-stop or on-off cycle of conventional HVAC systems. The bottom line result: constant comfort and energy efficiency. The energy efficiency of VRF systems make them ideal for applications that utilize renewable energy. VRF systems run on electricity rather than fossil fuels, with wider adoption of VRF systems essential for initiatives dedicated to lowering carbon gas emissions. There are many benefits to the technology, but beyond comfort and energy efficiency, VRF is known for design flexibility. VRF systems maximize space. As I mentioned earlier, they use small diameter piping to move conditioned refrigerant. This allows for smaller plenums and more open space for the interior of your building. VRF systems minimize mechanical space. Compared to conventional HVAC systems, VRF is also very compact. They offer a smaller footprint with more compact outdoor and indoor units. Applications can be ducted or ductless. Another benefit: VRF systems require less structural support. They are 30% lighter than alternative systems such as chilled water systems. This opens up opportunities for the roof to be repurposed to add a rooftop garden, restaurant, or other amenities, in addition to the units being very quiet. Some of the outdoor units have sound pressure levels that are as low as 56 decibels, which is actually lower than the sound level of a typical conversation. Let's talk a little bit about system types. Part of that design flexibility and footprint is your equipment options. Heat pumps are used in single zone applications and in moderate climates where all of a building's zones can be in the same mode at the same time, either heating or cooling. Here we show the heat pump example on the top here with all the indoor units in cooling mode, because again, you can only heat or cool at one time, not both. A good use of a heat pump might be in situations where you don't have a varying thermal needs. One example might be an auditorium. You don't really need to simultaneously heat and cool this single space, so you would opt to either heat or cool the area. For example, if it's warm outside and the auditorium is full, you'd need to cool the entire area. If it's cold outside and only a few people in the room, you need to heat the entire area. So again, here you see the units in the all cooling mode on the top example. Heat recovery systems, on the other hand, offer simultaneous heating and cooling. So here in this example on the bottom, again, you can see the outdoor unit connected to a variety of indoor units. But you can also see with the depiction of the blue and red lines that some areas are in heating mode and some are utilizing cooling. So how does this work? This is accomplished with the use of the branch circuit or BC controller, which is the unit you see there between the outdoor unit and the collection of indoor units. The BC controller directs refrigerant based on the conditioning needs of a particular zone and whether it needs heating or cooling. So each area or zone has its own indoor unit that provides heating and cooling. An example of this might be a building with a lot of exposed glass. When the sun comes up in the morning and hits one side of the building, that heat generated by the sun against the glass might require for zones on that side of the building to be cooled, but on the other side of the building, still in shade, it might be necessary to heat those areas. Another good example might be hotels, just because of the varying needs of the multiple rooms and multiple guests in those rooms. So to sum it up, VRF systems with heat recovery are the ideal choice for office buildings, hotels, and any facility with diverse comfort needs. Now let's talk a little bit about the difference between air source and water source. VRF systems can be applied in two configurations, air source and water source. Air source systems use air as the heat transfer medium, expelling rejected heat into the air outside of a building. Water source systems use water as the heat transfer medium, expelling rejected heat into a water source typically located inside the building. Both configurations, air and water, maximize energy efficiency. Finally, due to the design flexibility of VRF, it can be applied to a variety of building types and applications. Again, air source systems heat and cool refrigerant with air. Water source systems rely on chilled or heated water to regulate refrigerant temperature. Note that water source systems usually require third-party equipment as a geothermal water loop or water tower. Geothermal water source VRF systems are typically sought after for energy efficiency because they regulate the refrigerant temperature through the Earth's relatively consistent underground water temperature. While VRF is a mature technology and preferred in Asia and Europe, as I mentioned earlier, VRF manufacturers continue to innovate and move the technology forward. Recent examples include greater use of innovative sensors and outdoor units with four-sided heat exchangers. VRF solves modern building challenges. The demand for sustainability has pushed the architectural, engineering, and construction industry to move toward designs and standards that reduce loads and energy consumption along with carbon emissions. VRF systems are equipped with variable capacity compressors to heat and cool low load environments with less likelihood of short cycling compared to traditional systems. And we talked about the inverter driven compressors earlier. HVAC systems are sized for design temperatures. By varying capacity, VRF systems only use the precise amount of energy needed to maintain set points. Since design day temperatures only occur during 1% of all hours in a year, this saves energy and money 99% of the time. VRF systems are electric powered and do not burn fossil fuels for energy. This helps buildings to reduce carbon emissions. Much of the drive towards building modification comes from both voluntary and policy-driven programs. Here we detail two examples, programs driving this change. First, the voluntary program. The 2030 Challenge aims to reduce carbon emissions through carbon-neutral buildings by 2030. The challenge is now standard practice at most leading architecture, engineering, and construction firms. Regarding the policy-driven program, The New York City benchmarking law requires properties bigger than 25,000 square feet to report on annual energy and water use. Building owners will be fined if the CO2 emissions produced per square foot exceeds the limits established for the category of the building. In summary, with VRF running on electricity instead of fossil fuels, it's the preferred heating and cooling system of the future. And in many cases, buildings will be retrofitted with the equipment. In summary, the reality is engineers, building owners, and facility managers must be prepared to specify, design, and work with VRF in conjunction with third-party equipment. VRF equipment is typically the most sophisticated HVAC equipment a building will use. Whether new construction or in a retrofit with existing equipment, VRF technology will need to be integrated and controlled. As for the management of these systems, the most efficient and beneficial way to do this is through VRF manufacturer controls. So what does this mean? I'd now like to turn the presentation over to Tom, who will dive into this topic. Tom?
Thanks, James. Great job. Hello, everyone. My name is Tom Greco with Mitsubishi Electric Trane US. Thanks for taking the time to join us today. As we work our way through today's content, please feel free to submit questions about the different controls options and scenarios that we're going to discuss. We'll do our best to get to as many as we can. As James noted earlier, because of the efficiency and overall demand for VRF technology, more of today's current buildings will require VRF technology to integrate with third-party HVAC equipment. This third-party equipment could include mechanical ventilation equipment, auxiliary heating systems in colder climates especially, and additional safety controls. VRF sensors, controls, and mechanical components are in constant communication. The breadth of information and control made possible by fully integrated VRF systems includes personalized comfort control for occupants, automatic adjustments based on the location and number of occupants in a zone, energy allocation, and centralized control for facilities managers. VRF systems use more sophisticated electronics than any conventional system. Facilities managers gain access to most system points and obtain peak performance when they use a manufacturer-provided control system to manage VRF systems and supplementary equipment in the building. Facilities managers can monitor multiple zones across multiple buildings, set operating schedules, and adjust equipment remotely. Varying levels of accessibility are also possible. For example, one facility manager might have an enterprise view to allow for reporting, status, and master control of several buildings, while other staff members may have access to only a select set of functions or buildings. Controls using open architecture give the building owner and facility manager freedom to switch service providers if they desire. Interoperability with third-party equipment that use the same proprietary platform is also key. VRF manufacturer controls engineers help with mapping out and identifying what points must be shared between the VRF system and the building automation system. This approach is common in hospitality applications, where such integration empowers the front desk to address complaints and comfort issues through a guest management system without getting facilities involved. For greater control and insight into the operation of both VRF and third-party HVAC equipment, the VRF manufacturer can provide a controls platform for the facility. Building owners and facilities managers can achieve peak performance of their VRF systems, achieve more efficient operation, and access a deeper array of VRF system points. VRF manufacturers may also offer a package control offering that provides system points beyond what's available through a standard BACnet protocol. VRF manufacturers can also help with energy allocation for tenant billing and other customized control and energy offerings. For example, our newest controls innovation, the Building Connect Plus, is a simple, secure, cloud-based controls platform for managing city multi-VRF systems, third-party BACnet devices, and hardwired equipment with one convenient interface. The panel can auto-discover and seamlessly connect up to 50 city multi-VRF indoor units, 5 BACnet devices, and 8 hardwired devices using a digital input-output. All of this is configured through an easy-to-use web portal. This innovation is an ideal solution for small to mid-sized buildings. It's well-positioned to be a solution for facilities managers who need more than a standard centralized controller, like we talked about before, but need less than a full building automation system. Now that we've talked about and understand the basics of why a VRF manufacturer control could be helpful, let's discuss some of the third-party components and systems that could also be integrated with VRF. More than ever, ventilation is critical. VRF systems and their controls streamline the integration of many types of ventilation systems. VRF systems provide zone filtration and allow the integration of ventilation air. Each zone has a filter to reduce contaminants such as allergens, bacteria, and dust, but they cannot provide ventilation or dehumidification. VRF must have a ventilation system added for optimal health and wellness. To ensure compliance with the ventilation requirements of ASHRAE's Standard 62.1 and the International Mechanical Code, HVAC specifiers will typically apply VRF systems with an energy recovery ventilator, ERV, or a dedicated outdoor air system, DOAS. Let's talk about how ventilation can be laid out overall. Dedicated outdoor air systems, or DOAS, may be applied with a VRF system in an integrated design where conditioned outdoor air is ducted directly from the DOAS to the VRF indoor unit as seen here. Conversely, DOAS may be applied with VRF systems in a decoupled design where conditioned air is ducted from the DOAS to each zone. In decoupled designs, the VRF system handles heating and cooling for each space. The temperature control is supported by the DOAS that conditions the ventilation air to room neutral before it reaches the VRF indoor unit. The decoupled approach requires a 2-duct distribution network, but it simplifies fan balancing and ventilation rate verification to prove compliance with ASHRAE 62.1. Specialized mechanical systems engineered for the use with VRF are also equipped with inverter-driven compressors to increase energy efficiency and satisfy the requirements of AHRI Standard 920. This includes moisture removal efficiency, MRE, as a full load efficiency metric, and integrated seasonal moisture removal efficiency, ISMRE, as a part load efficiency metric. Recognizing the importance of mechanical ventilation, some VRF manufacturers now also provide DOAS units designed to utilize the same communication protocol as their VRF equipment. In an input-output scenario, the third-party DOAS would use its own controls to regulate functions such as discharge air temperature, but the VRF system would dictate when the DOAS would turn on or off. Through a direct VRF controls integration, the facility manager could also establish a schedule where the DOAS would run potentially from 8 to 5 each day. Let's look at a restaurant scenario. Obviously, many restaurants right now are at half capacity, but even so, ventilation is still a high priority. VRF systems provide energy-efficient comfort in restaurants that experience fluctuating heating and cooling loads as guests transition in and out. However, even if the restaurant uses a DOAS to provide conditioned outdoor air to staff and guests, the amount of grease and debris produced by commercial kitchens means that restaurants typically require a third-party packaged rooftop makeup air unit. So the solution? A third-party mechanical ventilation system that natively uses a different proprietary protocol could be integrated with a VRF system via a simple input-output connection. The same I/O method could be used for third-party DOAS and would coordinate the operation of the makeup air unit and the exhaust fans. Some ventilation applications may have a special requirement that necessitates the use of a third-party air handler to provide capabilities such as supply air control and complement the VRF system and the DOAS. In response to this need, manufacturers offer a linear expansion valve kit, or LEV kit, to connect an expansion coil of a third-party air handler to a VRF-style condenser. This is also useful in a retrofit application that include existing third-party air handlers but want to use newer VRF systems. Now that we've covered ventilation, another type of third-party equipment that may need integration with VRF is auxiliary heating systems. Contrary to past perceptions about heat pumps and variable refrigerant flow technology, these systems do extremely well in cold climate applications. As an example, our City Multi hyperheating H2I units are able to provide 100% heating capacity at 5 degrees and up to 78% of their rated capacity down to -13 degrees Fahrenheit. That said, for extreme temperatures below that threshold, and I'm sure many of you can remember last winter's polar vortex that hit the Midwest, supplemental heat is definitely preferred by most designers. With that being the case, here's an example of a VRF system with auxiliary heat integrated into the VRF manufacturer's controls. VRF controls can be configured to activate a backup auxiliary heating system. As required by the application, VRF controls can manage almost any kind of supplemental heating, including but not limited to hot water baseboard heating and electric duct heaters. Lastly, depending on your facility, whether an office space, multifamily building, or other application, you may need to integrate safety controls alongside your VRF system. Especially in buildings with several points of system integration, safety monitoring is critical and may require additional equipment. In addition, depending on how many occupants use the space, it may require the use of a third-party safety equipment control. For this scenario, we're actually going to reference a real project that we've worked on in the last few years. In the summer of 2016, Uber Advanced Technology Group officially opened its doors in downtown Pittsburgh. As the main campus for Uber's autonomous vehicle research and development, vehicle testing garages sat side by side with state-of-the-art conference rooms and office spaces. Monitoring the exhaust coming from the cars in the garages and fumes was a top priority for the facility's management. The solution? A Diamond Controls Niagara-based offering was implemented at Uber's facility so that managers were able to track everything and control each piece of equipment from a secure and remotely accessible platform. With that in mind, it's a good time to talk about yet another exciting offering in the world of controls and integration to VRF. Just this past July, Mitsubishi Electric and Trane Technologies collaborated to bring industry-leading VRF technology and a premier building automation system together. Trane Tracer SC Plus now integrates directly into Mitsubishi Electric City Multi VRF with a huge data points list, pre-engineered graphics package, and market-leading mobile capability. For more information about this, contact your local Mitsubishi Electric Trane HVAC sales rep or get in touch with your Trane Technologies commercial sales office. So what about buildings with existing equipment? There's plenty of new buildings with VRF and third-party systems, but it's also common to install VRF systems into a building with existing equipment during a retrofit. The existing equipment might continue to serve certain zones or might be used in conjunction with the VRF technology. That said, understanding how VRF integrates with existing HVAC equipment is very important. Let's detail a scenario in an existing school building. The VRF control system, which provides control, monitoring, alarming, and data management, was configured to manage the chill water loop in addition to the VRF system. The temperature differential between the chill water supply and the chill water set point is assessed by the VRF system to determine the required water flow to meet demand and rates it from 0 to 100%. The primary pump and chill water have user-selectable lead lag status. Per the calculated chill water demand, the primary pump and associated chiller stage up and down. The secondary chilled water pump is equipped with a variable frequency drive and modulates to maintain differential pressure across the secondary loop. The temperature reset for the chilled water is accomplished via the VRF control system. Lastly, while we're on the subject of existing equipment in a building, we especially wanted to highlight water source applications. If you're working on an existing building that has a boiler cooling tower setup or a geothermal well system, they can be integrated with water source VRF. Water source VRF is highly efficient if you're retrofitting for sustainability and can lead to substantial utility savings over time. With its condensing unit located indoors and less subject to outdoor elements, water source VRF systems experience minimal capacity loss compared to air source systems in extremely cold weather. Managing the repurposed boiler and cooling tower through the VRF controls simplifies operation for facilities managers as they take advantage of the energy efficiency and low D rates of water source VRF systems. We really appreciate everyone's time today and hope that you found the content valuable. We also know that we delivered a lot of content very quickly. That said, please remember to submit questions for the Q&A at the end. We'll do our best to get to as many as we can. Thank you all and take care. James, back to you.
Thank you very much, Tom. I know Tom talked about the Uber example in his presentation. That's actually a case study that we have that we've turned into, but I did want to share another case study with you briefly. And this is the Garrett Jacobs Mansion. The Garrett Jacobs Mansion is a historic 4-story home in the Mount Vernon neighborhood of Baltimore, Maryland. Built in the late 1800s, the celebrated building, preserved by the state historical easements, has been home base for the Engineering Society of Baltimore, the Engineers Club, since 1961. A few years ago, the Engineers Club realized patrons required more accessibility to the upper floors of the mansion, as well as a streamlined HVAC system. The club decided to build an adjacent 5,600 square foot tower that connects to the building, providing access to an elevator, stairs, accessible washrooms, and additional storage. With several different types of conditioning systems and outdated boilers, the building was running inefficiently and couldn't satisfy the venue's comfort requirements. Adding VRF is a part of a multi-year plan to completely modernize the building's HVAC system. Ultimately, Mitsubishi Electric's R2 series system with a Losnay energy recovery ventilator, the ERVs that Tom mentioned earlier, as well as an AE200 centralized controller, was selected for the addition. In addition to the tower, the new system conditioned some rooms on the second floor of the mansion, areas that previously did not receive conditioning or modern ventilation. And just a couple of quotes from the people that worked on the project. From Smiley Elabad, a commercial area sales manager for Mitsubishi Electric Trane. He said, quote, "With historical buildings, it is so common that a person will add on one system, then another will choose a different one, which can have some negative implications. With Mitsubishi Electric VRF, it's so easy. You can expand the system as needed while tying everything into one integrated control system." Then from the customer side, Corey Collisard is Vice President of Spears, Vada and Associates, which was the engineer that worked on the project. This project is an opportunity to improve the building, improving operating costs, give the Engineers Club flexibility, and allow them to have individual temperature control in multiple rooms. It's an improvement that's generating a master plan for moving forward instead of putting a bandage on the conditioning issues as they arise. In summary, and some of the key takeaways from today's discussion, VRF is emerging as a preferred energy-efficient heating and cooling system. VRF systems are typically installed alongside other types of HVAC equipment. And as Tom went through, there are many ways to integrate VRF technology into existing or new buildings. And lastly, VRF manufacturer controls can make this integration seamless. That concludes the prepared portion of today's webinar. Tom and I enjoyed discussing VRF technology and how that technology can be integrated with third-party HVAC equipment, and also how VRF manufacturer controls can be used to set up this integration. And we shared a couple of examples on how these can work. We hope you found the information to be valuable, and we look forward to answering your questions in just a few minutes. But first, we'd like to highlight a few resources, among many others, available for your use after this presentation concludes. These resources include our website that you can see there, META HVAC, META-HVAC.com. There's also a link to our quarterly engineer, architecture, facility manager, and building owner newsletters. If you'd like to review the full case study that we just talked about, as well as the Uber example that Tom went through, there's also other examples in our case study library where there's over 150 case studies across various types of applications, from office buildings to schools to hotels to mixed use and many more. And then lastly, a link to find a VRF distributor to learn more about VRF. On behalf of Tom, thank you again for your time and attention today. And with that, for question and answers, I'll turn the presentation over to Andy, who will be our Q&A moderator for this portion of the webinar. Andy?
Thank you, James. Thank you, Tom. Fantastic presentation. We have a diverse set of questions from people of varying levels of familiarity with VRF, so let's get right into it. First question. Do VRF systems support tenant billing applications or energy apportionment?
Yeah, I'll jump in on that one.
Go ahead.
Oh, yeah, sorry. I'll jump in on that one. So absolutely. So especially in the New York City area and in some areas in California, and pretty soon in the Boston area around me, tenant billing is going to become a huge factor. We prefer to call it energy apportionment, but the onboard central controller that you saw early in my section of the presentation actually has an energy apportionment feature built directly into it. And what it does is it's able to use the amount of work that every indoor unit is doing, and with the use of a third-party electrical meter to capture the use from the system, you can apportion the individual tenant's electrical use in kilowatt hours, and then based on the region or the utility, the building owner can then make determinations about how much energy every individual tenant is using. So absolutely, my group, the controls applications team, is heavily involved with setting up energy apportionment and tenant billing systems, especially in the New York metro area. If you have a specific need for a project, please don't be hesitant or shy to reach out. It's casales@hvac.mea.com. That's Charlie Alpha Sales. So controls application sales, and we can help you with that.
Okay. Thank you, Tom. So the next question. Can new VRF systems be connected to an existing building automation system or a new one, a new building automation system or BACnet system specifically? And Tom, I think you're probably raring to go on that one, so I'll just let you have it.
Yeah, I'll take a swing at that one, sure. So yes, the answer is yes. So the central controller, again, the same one I just mentioned earlier, has a built-in standard BACnet license that for a fee. You turn on the BACnet over IP connection capability, and any building automation provider that's familiar with BACnet, which should be all of them, can get a set of points for monitoring and control out of the central controller. As you saw us, we mentioned several other methods to enter into the world of commercial building automation. We have a Building Connect Plus product, which is now directly in the cloud. We have a new integration directly to Trane Tracer SC Plus, very exciting. We just released that. And we have a Niagara-based offering called Diamond Controls that fits a couple of needs, including the Uber example. So any of those flavors of integration mostly lean towards BACnet and have a few different capabilities with integrating to an existing system or a new system. So yes, yes, and yes.
Okay, great. All right, so we have a couple of questions with regard to the cost of VRF systems. So specifically, some attendees want to know how the installed cost of VRF might compare to some alternatives. I'll put that to both of you. I think.
Yeah, I'll start and I'll let.
Want to say?
I'll start and I'll let Tom add anything he wants to at the end. I mean, we touched on that a little bit throughout the presentation. I mean, certainly there are a number of opportunities where VRF is available to save on cost. I know a lot of time we hear, back from us that the upfront cost is a little bit more than traditional systems. But I think if you look at the opportunities that VRF allows you to, like we talked about, maximize space to possibly put in other potential revenue generating opportunities. It also, like we mentioned, less on the structural cost side. And then as well as annual maintenance costs. I mean, if you look at VRF, for example, in comparison to something like PTAC units that you might see in hotels or senior living facilities, I mean, if you look at the 10, the 15, the 20 to 25 year maintenance costs over that amount of time, I mean, it just continues to build up where you can save thousands and thousands of dollars with VRF over PTAC units, just as an example.
Yeah, I totally agree with everything James said. The other thing I'll offer is if you're talking about the cost in comparison to a 4-pipe, hydronic system where you have cooling towers and boilers and controls and pumps and water loops running all over a building, and the implementation of a VRF system, simultaneous cooling and heating system, is going to be extremely competitive. So if you have a layout that needs, or you have a project that needs that level of temperature control, the installation of our system, which is R2, our simultaneous cooling and heating product, you're absolutely going to be competitive with the total installed cost with a lot of the factors that James mentioned. So it can be more expensive up front if we're up against what I would consider, a less efficient or, less zonable product. PTACs and other systems that don't allow the kind of flexibility and energy savings are obviously going to be less expensive.
Okay, great. So let's go back a little bit, because there are some questions with regard to scalability of VRF systems and really the range of projects in which they can be applied. So briefly, are VRF systems only for small spaces? Are they for larger scale projects? What kind of applications can VRF systems be used for?
Yeah, I mean, we certainly have a number of different product lines. We have one series, S-series product line that can be used for large residential or light commercial type applications. And then with our R2 systems and water-based systems, I mean, you can really twin the units together, to go up, basically as high as you need. So I think you can work on smaller type project that might be a large home or small commercial retail strip center versus large school, office buildings, hotels. So I think VRF definitely has a number of different flexibility in different application types.
Just as an example, I like using examples, and we have a hotel project that's going in Manhattan right now that's I think 250 rooms. So it's a modular, it's a modular system. So you can just continue to bolt on more and more systems and loops, and it still all works in concert, but you just keep adding more outdoor units and more indoor units until you get where you need to go. I believe there was a 1,500 ton implementation somewhere down south, and the name of the project eludes me, but there's several multi-hundred tons of cooling and heating going into buildings. If you go through our case studies, you'll start to see that they can get pretty large.
So, Tom, I have a question for you that I want to ask real quick as a follow-up to a previous question. What's the email that someone would need to use if they had additional questions about energy allocation?
Absolutely, happy to share it. Yeah, for sure. It's so controls applications is my team, and the address to get in touch with us is CA Sales. So CASALES at HVAC.mea.com. And that goes to the entire sales team in my group, and someone will get back to you based on the region that you're coming out of.
Okay, perfect. All right, so let's get back to some technical questions. All right, well, this one isn't still technical, but what is the average useful life of a VRF system before it needs to be replaced?
Yeah, I'll start with that, and then Tom may have some real-world examples that he wants to share. But I know when we look at the systems that were first introduced into the U.S., as I mentioned, over 15 years ago, and some of those original units are still in use today. So I think if you look at the long-term life cycle of how long the outdoor units themselves last, I mean, you're looking at 10 to 15 to 20 years, or even more on those. And I think sort of tied to that is the minimal maintenance that you have to do with the systems. I mean, it's basically just routinely checking on the coils and cleaning the filters, which are reusable and can last up to 10 years. So I think there's a number of different advantages on the long-term life of the products.
Well said, James. No further comments.
All right. Then on to the next one. So there were a few questions with regard to cold climate performance. One of them inquired about truly extreme climates down to negative 30 degrees. So can we talk about scenarios in which we could use air source systems and water source systems?
Yeah, I'll start with that and sort of give a bit of an overview, and I'll let Tom give his answer after I give sort of an overview of the products. With our systems, as we talked about, we kind of highlighted the water source systems in the presentation, but also with our heat recovery systems, we actually have a tiered product lineup with standard efficiency, high efficiency, and hyperheating inverter technology. And those products, depending on the standard efficiency, high efficiency, or H2I performance, specifically with the H2I products, which are really designed more for the colder climates, those basically have operating up to minus 31 degrees. So with the H2I enhanced compressor, it basically reduces the need for any type of auxiliary heat, because the compressor can kick in and really supply that heat even at the low base temperatures. And I'll let Tom add anything he'd like to.
Yeah, I'd agree. If you have a design day temperature of down in that range, you're definitely going to be looking at a water source system and definitely a backup source of heat for that kind of application for sure.
Okay. Let's move on to another technical question. Thank you both. Can VRF fan coil thermostat controls perimeter heating control? Wait, hold on. I read that incorrectly. Can VRF fan coils thermostat control perimeter heating? Wow, heating control valves. Can it turn off? Can it turn off the heating control valve during cooling mode?
I'll take this one. That's a great question. The answer is yes. So, no, I knew what you meant, Andy. Don't worry. So it's actually not the thermostat itself. It's actually going to be the indoor unit control board itself. So there is a few ways to tackle this. It can be a lagging heat source, so a perimeter baseboard or a perimeter, maybe even a radiant flooring valve, which we've seen in the past. You'd actually wire it directly to a contact on the indoor unit's control board, and all City multi-style indoor units have that capability. The other thing that we've done in the past, and that ourselves or Trane or any other building automation provider would be able to do, is implement a building automation system that would work in concert with that contact to make sure that the heating and cooling isn't running, the auxiliary source of heat and the VRF cooling are not staged on at the same time. So the answer is yes. It just wouldn't be the thermostat itself. It would actually be the indoor unit.
Okay, great. There are a few questions about troubleshooting. So can we talk about how controls can facilitate troubleshooting and uncovering and solving common issues?
Yeah, absolutely. So one of the great things about VRF, and especially Mitsubishi VRF, that I learned through my time here, is that the onboard diagnostic and the sort of self-awareness that the system has is pretty amazing. There are hundreds and hundreds of error codes, fault codes, pre-alarm condition codes, all kinds of stuff for the indoor unit, the outdoor unit, the branch circuit controller, the comm lines. It's an incredibly intelligent system, and it pushes out little 4-digit codes that refer you to a service manual that's about the size of a phone book, and it gives you everything from possible causes to potential ways to fix a problem or troubleshooting steps. It's really pretty great. So any building automation system, including the ones that we provide, that Trane provides, that anyone else would provide, can actually give the numerical value through the system and show you where to start if you have some sort of a fault code. So and now that a lot of our controls are getting into the cloud and things are becoming more remotely accessible, we're able to do those things without even being at the job site. So it's pretty exciting stuff. And yes, we have a lot of that stuff is high on the priority list when it comes to integration.
Okay, great. This is kind of going back to fundamentals, but there are some questions with regard to how VRF systems handle fresh air ventilation. So are separate makeup air units required, or exhaust fans? What do you do for ventilation when you apply a VRF system?
Yeah, I can start on that, and then I know one of the examples Tom used was in the Uber example. He was talking about bringing in fresh air with a DOAS unit and some ERVs, but basically from Mitsubishi Electric Trane's perspective, I mean, there's a number of different ventilation products that we have. As I mentioned, the rooftop unit, which is for more larger applications, the dedicated outdoor air system. We also have the ducted outside air unit, which is really ideal for more zone ventilation applications. It's really an ideal choice for office buildings, schools, hotels, assisted living, where the ceiling space is available. And then lastly, the Losnay energy recovery ventilators. Those are also a good opportunity to bring in fresh air from the outside while removing stale air from the inside of a building. And actually, with the Losnay units, we actually just introduced earlier this month a MERV 16 filter that's an optional filter for those Losnay units, which remove I think it's 99.7% of contaminants coming in from the outside air. I'll let Tom add anything he'd like.
Nope, well said. Same answer. You know, we can integrate. You need, you know, ventilation and humidity control. VRF systems standalone usually aren't gonna do that. So that's why we have some of our own options. Obviously, Trane has good options. There's a lot of good options, and how you integrate to it is you know, vitally important.
Okay. This next question is with regard to, well, I'll just read it. How do VRF systems control relative humidity in spaces when it's at part load?
Tom, I'll let you have that one.
Yeah, just total honesty. The VRF is a temperature control. You know, is primarily a temperature control system. If you have heavy, or I should say, very specific humidity control needs, whether it's humidification or dehumidification, you're going to want to have dedicated outdoor air systems, rooftop units, or even, you know, space by space, you know, humidity and dehumidification control. We can integrate with all that and make sure that the systems work in concert. But especially, you're bringing up a great point. You know, the energy efficiency of the system to run at very low speeds often, you know, it sacrifices latent moisture removal in favor of doing temperature control. One thing I will bring up is that we do have almost all of our systems, residential and commercial, have a dry mode in which it will consider humidity and moisture removal at a higher priority, but it still is never going to fully sacrifice temperature control in the room. So the short answer is, if you have very strict humidity control needs, you're going to want to integrate with other systems alongside VRF.
Okay. All right, so we have a lot of questions coming in with regard to energy allocation. I'm going to drop one more for this session. So in multifamily applications, how can a building owner meter the system per tenant or residential unit? And Tom, I'm
going to try to answer this in under a minute. I see the time, so I'll say that I'll plug my email address again. If we need to have a deeper conversation about it, I'm happy to do that. Or if one of the sales engineers from my team, we deal with this stuff a lot. So please don't be shy to reach out. The way that it does it is the system knows the linear expansion valve position of the indoor unit. And what it's able to do is, by way of realizing how much refrigerant is going through the unit, it knows the capacity of the unit, it knows how long it's spent doing thermal work, it knows, you know, the internals of the system know a lot of those variables. And then what you do is you put a meter on you design in a meter that captures the kWh usage of the outdoor unit, which uses about 99% of the electrical energy. The outdoor unit has got the compressor in it, the large heat exchange fan. So you take those two factors and you combine them, and what the system can actually do is say, unit A serves tenant A, and that used 12% of the energy today, and 12% of the energy is, you know, 4 kilowatt hours. So that's a real quick synopsis of how it works, but I can certainly give more detail in smaller sessions.
Well, I'm sure that'll whet someone's appetite for more information, but we are unfortunately out of time. So I'm going to thank you, James, thank you, Tom, and welcome back our editor, Warple, for some concluding remarks.
Thank you, Andy, and thank you, James and Tom, for a wonderful presentation. As they said, that wraps up our presentation today. Please join me in thanking James DeBerry and Tom Greco, as well as our sponsor, Mitsubishi Electric Trane HVAC US. If you have any additional questions or comments, please don't hesitate to email us at webinars@bnpmedia.com. As you exit today's webinar, please take a couple of minutes to complete our survey. We encourage your detailed comments. Please visit www.esmagazine.com/webinars for the archive of this presentation, as well as information about our upcoming events. We appreciate your time and hope you have found this webinar to be a valuable experience. Please enjoy the rest of your day.